So I've started 9.1b with this page just to remind us that these are all the facts we can use. Algebraically, they are equivalent things that we can use substitution for. So you have to know these facts. You have to have access quickly to these facts. So again, if you haven't made a screenshot of these facts, put these facts on your camera roll so you have it. Now let's get started. So for the first time, we have the language. It's a little different than the problems we saw in 9.1a. It says the words verify a trigonometric identity. Now, verifying an identity means I know for a fact that this will simplify to a sine, or there's some way I could turn a sine into a tangent times a cosine. And our job is to show that they match. Now, to verify a trig identity, you get to pick. You're going to leave one side completely alone, and you want to think about as that is my answer. So in this case, I'm going to leave that very simple side of sine as my answer. So my job is to get this to match that. And what's nice about this is you know the answer. I know the answer is sine. Now, unlike most equations where we can manipulate and move things from side to side and we can multiply both sides by the same thing, you cannot touch the right side in this particular one because we're going to keep the sign alone. We're going to verify that we can turn the left side into a matching equation. Well, one of the substitutions we know is that the tangent is the sine over the cosine. Now, some of you are those kids that don't like to show any work. The verification is showing all the pieces of your work. So you have to show every step. Every step is every substitution you make, every algebraic simplification you make. You have to show it, you have to show it, you have to show it. So what we're going to do here next is I would put this over 1, and I would physically show that at this point, I am allowed to cross those up. And I get the sine of theta divided by 1, which is the sine of theta. I got them to match. And the notation is, you could keep writing the sine, but instead, to save yourself some time, just write it at the final location and put a little arrow in between. So I can see that arrow kind of shows me, as your teacher, what side you kept. And then I know that you were taking the left side and switching it up and changing it up and substituting and doing algebra to get it to match. Okay. Now you don't have to hold the right side. You can manipulate either side, but I usually take the simpler side. So in B, I am going to hold the 1. I'm going to think, oh, I know the answer to this is 1. I'm going to hold it, and I'm going to manipulate the left side so that I can get the answer to be 1. Now, when you have lots of trig functions like this, we're going to substitute in the facts we know related to sine and cosine. Always go with sine and cosines. Cosecant is the same as 1 over sine. We're allowed to substitute that in. Cosine's ready to go. To write it as a fraction, just put it over 1 to show that it is a thing that's in a numerator. And then tangent is sine over cosine. Now, you can at this point cross out, but kind of color code it. Show me really what you did. I crossed out these cosines. I crossed out these sines. I got 1 over 1, which is equivalent to 1. Right at the final stage, put an arrow in between. So I have showed in detail why it was equal to 1. Let's do another one. Now, here's for the first time where we're going to use the even and odd identities, so we'll get to that in a second. Okay, so we need to hold the equations that we think looks the simplest. So it just so happens again that this one does seem to be the simplest. My goal is to get the left side to match it. Now I can't touch the right side. That's my answer. My answer is the cosine squared. And let's show how we can get them to match. The one thing I notice here is this is the first time I've seen a negative on the inside. Now there's an identity, a rule that says something about the sign of negative x. Now the cosine and secant are the only ones that have y-axis symmetry. So all our other functions are odd. So if you see a negative on the inside, you can bring the negative on the outside. So that's the trick we're going to use. This, we can bring the negative on the outside. So this becomes 1 plus the sine of x times 1 minus the sine of x. Again, we're not touching the right side. Now, algebraically, this should remind you of the difference of squares, a squared minus b squared. This should multiply out nicely. So let's multiply it out, show every step. Remember, verifications, you have to show every single step. So this is going to be 1 minus the sine plus the sine minus the sine squared of x. Show that these two cancel. We get 1 minus the sine squared. Oh, that's a Pythagorean identity. I know that sine squared plus cosine squared is equal to 1. So I know that cosine squared is a perfect replacement with 1 minus sine squared. And that's what happens here. We replace it with cosine squared. We've got a perfect match. Write it down there once, put an arrow in between. So we have shown that 1 plus the sine of x times 1 plus the sine of negative x will equal a cosine squared every single time. Let's look at this one. Hold what seems to be the most simple side. Now fractions, I like to manipulate a fraction because I have more to work with. Okay, so we have some information about squares and ones in our Pythagorean identity. So there's a rule that says that tangent squared plus 1 is equal to secant squared. So let's think about how we could change this so these two matched. Well, we got to take this 1 and scooch it on over. And if we scooched it over, tangent squared is secant squared minus 1. So that's a perfect replacement, and that's what's going to go on top. So we can replace secant squared minus 1 with a tangent squared. Now we're looking for a sine squared. So since I don't have a sine squared, but I know that tangent is sine over cosine. So tangent squared is sine squared over cosine squared. So let's take that and let's make the tangent squared sine squared over cosine squared. Let's make a secant squared 1 over cosine squared. And I found that sine squared that's hiding. And now I'm going to do big C over little c. Well, the big C is going to go on top. So that's sine squared times cosine squared. Little c is going to be on the bottom, cosine squared times 1. Show all the steps. Show what's going to cancel. Our cosine squared is going to cancel. So we get sine squared over 1, which is equal to sine squared. That was our answer anyway, so put it on both sides. Put your arrow notation. So you have the answer was a sine squared. We showed that we could get a sine squared, and there you go. Let's do it again. I am going to hold this right side. I'm sorry they're always holding the right side. You can manipulate either side, but cotangent is cosine over sine. Cosecant is 1 over sine. And here is another opportunity for us to do big C over little c. Now the big C are going to multiply on top. Little c is going to multiply on the bottom. Show all the steps. Show that our signs are going to cancel out. We are left with cosine over 1, which is equal to the answer we were looking for. So write it on both sides once you find the answer and write your arrow notation. Let's do another one. I think this, even though it has a fourth power on it, is what is good to hold. Tangent squared plus 1 is equal to secant squared. So that is a perfect replacement. Oh, I'm sorry, they used x's. Since sine squared plus cosine squared is equal to 1, then cosine squared is equal to 1 minus sine squared. So that is a perfect replacement with a cosine squared. Now we need everything to turn into secants. Now we know that a secant is a 1 over a cosine. So if we kind of separate these items, because you really want to show where things are coming from, 1 over a cosine squared is the same as a secant squared. Keep looking back at your answer. I want secants. I want secants. What are secants? They're 1 over the cosine. And so I have 4 of them, which is exactly what I was looking for. So put it in the correct notation. These are puzzles. You have to figure out what is hiding there that I can replace so that I can get the answer that I know is right there on the page. Okay, last one. Now, this one, I don't see a lot I can work with, except on the right side. This time I'm going to hold the left. And it's, if you decide to hold the right, it's perfectly fine. Okay. I need to turn things into cosines. I have some information about a sine. Sine squared plus cosine squared is equal to 1. So if I want to get what sine squared is equivalent to, I just have to subtract the cosine to the other side. So that is the same as 1 minus cosine squared. The two ones add together, and I got a perfect match. So some of them are a lot easier than others. It just depends upon what you decide to substitute, what rules they've combined to get the two things that are equal. So these are going to take a lot of thinking and a lot of time. Do not wait till the day that they're due to do them, because you want to be able to ask me questions, and I can go through some things, but only if you ask me questions. Okay, and that is your 9-1B homework that follows. So there's that.